At reInvent 2022, AWS released SnapStart, which is a Lambda feature achieving up to 10 times faster function startup performance on Java functions. This is great, but we can wonder where does it stand against other runtime and other Lambda configurations. And unfortunately, we can find some benchmark on the web, but they are not always up to date. Luckily, we have Maxime with us today, who is passionate about serverless. He's a senior software engineer at Datadog and actually presenting some serverless topics there. So please give him a round of applause. He will present an up-to-date live benchmark.
Thank you so much for this introduction. And hi, everyone. Glad to see that you're still here. Last talk of the day before the closing keynote. So yeah, today we are going to use serverless to build a Coldstart benchmark across all runtime. That's a quite long title, but yeah, I hope it's going to be fun. It's going to be a bit different from other talks, mainly focusing on actually showing you Lambda code and like doing some live demos. So yeah, I hope you'll like it. And thanks to the awesome previous speakers, I won't have to define Lambda or serverless, so thank you so much. So who am I? My name is Maxime David, Max Day. You can find me at Max Day on GitHub. I'm doing serverless stuff at Datadog, mainly working on an extension, which is Lambda sidecar, which gather telemetry. I'm an AWS community builder. I know there's a lot of heroes today, but I'm still a community builder. And yeah, I'm a YouTuber in Rust, so I do live coding videos. And I already have 500 subscribers, so I'm definitely into the YouTube game or not. So yeah, if you want to follow me, feel free. And as you can hear, I used to be French, and I moved to Canada 10 years ago, so working from Montreal. And I'm a creator of Lambda Perf, and that's what we are going to talk about today. So yeah, let's dive into it. Fortunately, serverless and Lambda has been defined. And Coldstart, to be honest, has already been defined by Julian. But yeah, let's have a quick look at that. So function is not always on. As we saw earlier, when there's a big spike of traffic, Lambda will scale horizontally. But if there is no traffic at all, Lambda will not be on at all. It will be off. So to wake up a Lambda function, it takes an event, because Lambda is event-driven. And as Julian said a bit earlier, an event is coming, and the first 3 steps, which is download code, start environment, and code initialization. And finally, there is the unlock code execution. So this is for cold start on the very top, and on the bottom, it's for warm start. So when the function is already warm, we can process the event right away. So for the first 2 parts, download code and start environment, this does not really depend on the runtime. If you use Go or Rust or Python or Node.js, download the code and the start environment would be approximately the same. It will spawn a Firecracker VM under the hood. But then you have code initialization. And this is what we are going to see today, how different runtimes will impact cold start duration. So yeah, serverless, it's fine. Lambda, it's fine. Cold start is fine. So let's have a look at the tool. So here's the tool. Who already seen that this page before? OK, cool. So yeah, this is a live benchmark. So if I refresh it, I'm terrible at UI, so this is my best effort for CSS. But yeah, basically, it's a web page with 3 different dimensions. First is runtime. So for instance, we can see that Rust is a winner for cold start, only 15 milliseconds. And Java 8 is the loser for 549 milliseconds. So you can select different memory size, and we can select as well different architecture. And Rust is winning on all of those different metrics. The cool thing about that is it's updated, self-updated every day. So at night, every day, I'm destroying everything and respawn a Lambda function, invoking them, and compute the mean to display that on the web page. So it's already up to date, always up to date, sorry. So let's have a look at how I built it, because it's actually only based on serverless. So it's a bit of Inception, and I think it's funny, maybe not, but I like it. So yeah, what the agenda? Never too late. Why did I build that? How? So we are going to see how we build it, or we deploy it, or we run it, or we test it. Never too late. But this is a really honest talk. This is a side project, so I didn't do like TDD or test first. Like, to be honest, I just build, deploy, and then realize that actually people are seeing that web page. So maybe I will need some tests, and finally maintain it, because it needs to be always up to date. So we will talk a bit about that as well. So yeah, Coldstart are really important, and as Pierre said just before, it's really hard to find always up to date. There's a lot of blog posts about Node.js, Python, even Snapstart lately, but AWS is doing some great stuff to reduce the overhead of init start cold start duration. So we need to monitor that. For instance, when they released Node 18, it was less performance than Node 12. So not great, but now it's way better. And AWS is also releasing new runtimes, so we need like an always up-to-date benchmark. So this is why I built a tool. And to be honest, this is also like a good side project to practice serverless, because in my day-to-day job, I monitor serverless, but I didn't really own a serverless architecture. So I think it was a fun project to showcase Lambda, DynamoDB, and S3. And we are going to see that in a moment. So how it works, how to detect cold start duration. Then we need to invoke function. So we are going to see that. We need to invoke function. And AWS is providing us with very useful information. At the end of each invocation, they will emit a report logline, as you can see here. In this report logline, you have the duration, the memory size, and the init duration. So during cold start, there will be this information, very useful because this is the truth. So we need to capture that and to display that in the web page. So 3 steps: invoke function, read the report logline, and display it. Very simple, but a bit more complex to build. So this is the overall architecture. Don't be afraid, I'm going to walk you over every single component. But yeah, basically we're using S3, Lambda function, and DynamoDB. So not too complex, but at first it was really simple because I did the benchmark with only 2 or 3 runtimes. But then I heard some limitation due to the fact that I was spawning a lot of different Lambda function, API rate limiting, and stuff like that. We will see how to solve that. So first, we need to create a function. And for the benchmark to be as honest as possible, I chose to do only hello world. So there is no external dependencies. If you're using AWS supported runtimes, such as Node.js, Python, Ruby, Go, you don't need any dependency to write a hello world. Obviously, for like custom runtimes, such as Rust, even Go, you can use Go on provided runtime. You need to implement Lambda runtime API, so you need a library. I definitely try to choose the smallest library, but everything is open source, so if you don't trust it, you can have a look at the code. So hello world, because it's really simple. Let's compare Apple with Apple. Very simple. Apple, Apple, I'm still confused. So for Node.js, very simple example. We export the handler, we return status code 200. So that's the benchmark. For Node.js, really simple. For Python, it's really simple as well. But for Java, you need to compile it. So basically, you need to have a handler, and to be able to compile it for ARM and x86, I choose to Dockerize it, so GitHub Action would be able to build different architecture. Everything is available on GitHub, and yeah. So let's have a look at the first component, which is the S3 uploader. So the S3 uploader will loop over every runtime which currently exists. Then it will produce an archive, code.zip, and this code will be the source code of each Lambda function. So for each runtime, there will be a different architecture, a different archive, sorry. Then we need to upload this zip to S3, and that's it. So first step is loop over every runtime, build a hello world function, produce a zip file, and upload that to S3. So let's have a look at that. So all the code here is available on github/maxday/lambdaperf. It's an open source benchmark to show you that I'm not cheating. So if you spot a bug, feel free to open a PR. So basically, I have here manifest.json, which explain every single runtime, Node.js, Python 3.7, 3.8, the path, the architecture supported, because not every runtime is supported by both ORM and x86. So yeah, basically, what we do here is we loop over the runtime, we build it, and then we put this zip file into S3. So this is the first piece of architecture. Loop over the runtime, build it, upload it to S3. Then we need to actually deploy. So what we do here is we have a Lambda function which loop over every S3 bucket item that we just upload and create a new Lambda function. Because we need to be sure that this function is really fresh every day to make sure that we embed the very latest version of the runtime. So every day, everything is destroyed, and we run the function deployer, which loops over item we just put on S3 buckets and deploy again the Lambda function. Of course, we need that to be idempotent. We talked about that a bit earlier, because sometimes it's failing, and the script is running. Maybe we will see that there's some retries. So we just need to make sure that we're not deploying the same function twice, which will lead to errors. So it's idempotent. And to be idempotent, we need to delete the function first. So function will be deleted, log groups will be deleted, and then we will create the function. So if I run this function twice, the output would be the same. Then we need to invoke this function. So as soon as all the function has been deployed, and actually this is a lot of function. If we go back to the Coldstart, there is 1, 2, 3 in x86, it's like 21 runtimes. Multiply by 4, because there's 128 up to 1 gigabyte of memory. So this is like 100 function. Multiply by 2, because it's 2 architectures. So it's almost 200 function. And I'm planning to have different region as well. So for now, it's just US East 1. But if we multiply by 5 region, it's like 1,000 Lambda function. So it's not a huge amount of Lambda function. Maybe if you work in a big company, like 1,000 function is small. But for a side project, it starts to be quite big. So then we need to invoke. So once again, we are looping over the exact same manifest.json file to get the list of function. But we need to make sure that we are hitting a cold start. And as soon as we invoke the function once, it's not a cold start anymore. So one solution would be to wait for approximately 6 to 7 minutes to be sure that the sandbox will be destroyed, and then we can invoke again the Lambda function, but this will take forever for like 2,000 function. We don't want to wait for that. So one trick we can do, and Julian said that a bit earlier, is to update the configuration. So what's happening is the function is deployed, I invoke it, and then I had like a random environment variable with a random number. This function will say, oh, okay, I need a new deploy, so spawning a new sandbox, and then a new invocation will be done, so it's guaranteed to have cold start. So let's have a look at that as well. I think it's this one, function deployer, no, function invoker. So yeah, as you can see, the handler is here. We retrieve the path, the architecture, memory size, function name, and then what we do here for the number of invoke, which is 10, we invoke the function, we update the function, we wait a bit to be sure that the update function has been done. this could be a bit better, but once again, it's very honest side project, so we could have some events to make sure that we're not waiting too long or we're not waiting too short, but that's why I do it. And so it's invoke, update, and invoke again. This way, it's really a cold start. So function I invoked, so great. So this is the first of our 3 steps. We need to create hello world function, so zip file uploaded to S3. We need to trigger a deployment for each of these functions, and we need to invoke it. Next step would be to read the report log line, because each one of these invocations will trigger a report log line, which we can read, from which we can read the init duration. So next step would be to read that. And how to read it? That's a good question. We need to read the logs, and since Lambda are event-driven, remember, so the first event is direct invocation. I invoke a Lambda function, that's fine. But what is cool is when AWS is emitting a log, we can trigger a new Lambda function from this log. So a cool way to do that would be, as soon as I see a report log line, I want to invoke a Lambda function. And this Lambda function will be woken up by a report log line. So this Lambda function can read it and extract the init duration. And this Lambda function, report log processor, is the exactly same for every function, because each function will be invoked, the report log line will be emitted, and an event will be triggered to one Lambda function, which is the report log processor. So very convenient. If we look at the code here, I receive an event here in my function, and I'm doing a very nasty regex to extract the duration. And the Lambda call starts here is showing not only the init start duration, but also memory usage and duration. So this is why I'm extracting the request ID, duration time, build duration time. So once again, this is like a good pattern for AWS. No need to do extra stuff. We just wake up a Lambda function where we receive a log event. We parse this log, and we store that in DynamoDB. So at the end, we can see that I put the item in a DynamoDB table. So cool. Now we have our data to be ready to be processed. So this is architecture diagram of what's happening. So I have a hello world function for every runtime. So it's a bit more than 200. So I just put 3 examples here. And each time a Lambda function is invoked, a log is produced. It will be stored into CloudWatch, and CloudWatch will wake up another Lambda function, which I just show you. And then this Lambda function is extracting useful information and store that to DynamoDB. Cool. So now the first 2 parts are OK. We invoke our function, we read the report log line, and every useful information is in DynamoDB. So now we need to display it. So how do we want to display it? What we can do now is read information available in DynamoDB, build a JSON, and since it's really 100% serverless, I didn't want to spawn like an Apache web server or something like that, so I'm using GitHub Pages. And the cool thing about that is the Lambda function which reads DynamoDB and builds a JSON can access to my GitHub repository with a personal access token and actually commit a file. So let's have a look at that. So on the repo here, Lambda perf, you can access to data. And as you can see, there is one JSON file for every day. So I've been running this project for a while. But yeah, and today, 1 hour ago, there is 2 different files. So one with the timestamp of the dates. So every day has a different timestamp. And for the front end to be able to fetch the latest version of the JSON file, I just double commit the exact same file. Could have done like a symbolic link, but for the sake of simplicity, I just double commit the exact same file and I overwrite the last.json every day. So if we look at that, very simple. I respect the metadata pattern that we talk about today. Not really, because it's just the generation dates. But and we have the runtime data. So it's a big array with the runtime name, the display name to have like a cool name on the UI, and an array of init duration. And this is a long JSON file because there's a lot of different runtimes, a lot of different memory size, and different architecture as well. So cool. Now my Lambda function is reading DynamoDB, committing the big JSON file in GitHub, and I have a simple, very simple web application, very static HTML, CSS, if we can call that CSS file, which will fetch last.json, which will change every day, and boom, that's it. It's a bit more tricky because if some users are using that every day, and since I'm using GitHub Pages, we have no control on the caching mechanism. So every day it will fetch latest.json, but this file changed, but the browser and the headers did not get that. So I use a small trick. So if we look at what's happening here for the commit, if we look at prevent cache, I don't know why we can't see that, but I will show you directly. Code. Sorry. Script. Yeah. So what I'm doing here is I also update the script.js to append like a random number at the end. So each time the actual script.js is changing, so it will invalidate the cache. So it's a little trick, but otherwise we have no control on GitHub Pages. So cool. Now we invoked our Coldstart, we read the report log line, we display it, project done. Cool. End of the talk. So yeah, once again, we store the Lambda function in bucket, function deployer, function invoker, result builder, and that's it. Next, we need to deploy it, actually. And we're using serverless framework. We talk about the serverless framework a bit today. So what it does is it's really like a simple YAML file describing permission, describing Lambda function, events, and this YAML file will be translated into a CloudFormation template. This formation template will be uploaded to AWS, and the stack will be ready. Then we need to run it. And from the previous talk, we will see that I'm also scheduling events. This may be improved. But yeah, at 1 p.m. every day, 1 p.m. Montreal time, the event will invoke function deployer. At 1:45, it will invoke. And at 2 p.m., we will call the result builder. So definitely, we can be a bit smarter about timing, but it's working fine. Maybe someday 15 minutes won't be enough, but yeah, there is room for improvement. The project is open source, so if you feel adventurous, feel free to create a PR. So yeah, now we need to test it because yeah, Tim McManara, who is the author of Rust in Action, really famous book author, decided to tweet my project, and yeah, got like more than 153,000 views. So yeah, it's for me it's a lot. So I was like, okay, so it's not a side project anymore. Like on my own, people are actually using it. So maybe I need some kind of test. I can just release a new runtime, and hopefully everything looks fine. As you see, the infra is pretty simple, but a lot could go wrong. So yeah. Let's maybe stop the YOLO mode, and we need to have like a staging environment. So the cool thing about AWS is we have different regions. So we could deploy that to my production region is US East 1, but maybe for my testing, I could deploy that to a new region. And I'm going to show you how it's working. So once again, it's all open source on GitHub. You have a workflow, and I have my stack, AWS deploy. And as you can see, I have MFA just to make sure that my credential won't leak. And I have two options here. I can deploy the stack to UE East 1 or US East 1. And what it's doing is just reading a bunch of secrets and deploying with a nice force flag. So yeah, and how it's working, you can just go to Action, Deploy to AWS, and here you have the choice, enter your MFA code, and then you just choose the region. Is it staging or production? This means that it will not commit to GitHub, but basically it's doing the exact same stuff. It deploys the Lambda function, invoke it, build the JSON, so I can manually check it for now if everything looks good. If everything looks good, I create a peer from my peer, and I merge that to main, and I can deploy that to the main branch. So now we need to maintain it. Because the aim of this project is to be always up to date. So, I can track every SDK version from every runtime in every architecture. It's quite annoying to be always up to date. Fortunately, GitHub has a Dependabot plugin. And it's great because I'll show you the configuration in a moment. But as you can see, 3 hours ago, it has opened a PR for me. And if I look at that, I can check the file change, and cool. The Quarkus plugin migrated from 3.1.0.final to 3.1.1. Obviously, I don't want to go every day for every runtime, look after the version, so I just need to merge it, deploy that to the non-production environment, making sure that everything looks good, and then deploy that to production. So Dependabot is a great tool, especially for this use case where you have so many runtimes, so many dependencies. You can't keep track of that manually. Maybe one addition that I could do is auto-merge this pull request and see with integration testing if it's working or not. But for now, this is it. So configuration of Dependabot is really simple as well. You have different runtimes. So, for instance, the .NET 7 is using Nuggets, so it's connecting to the Nuggets package dependency. For Go, it's Go mode. For Java, it's Maven. For Java 8, it's Gradle. So it's very convenient. You just have to write like this 77 line of YAML file, and Dependabot will update the dependency and create PR for you. So very useful, not only for this project, but if you want to be always up to date, that's a good thing. Obviously, if you have like a good CI with integration testing, you can select the auto merge feature, and then it will revert if it's not working. So that's really a great tool. So yeah, first, I just show you the manifest JSON file, but at first it was not that easy to add a new runtime, and I have some contributors, about 15 contributors, and also a lot of different issues about like asking new runtimes, and it was a nightmare for a new contributor to create a PR and contribute to this project. So I tried to refactor this architecture to make it simple, and recently I've added support for ARM and different function size. So if you like the tool, if you want to play with it, once again, it's fully open source, looking for contribution. Yeah, I think that's it for me. Yeah?
Thank you very much. Does anyone have any question? Yes.
Thank you for the talk. It's really interesting.
Cool.
I've used the site before. It's really great.
Thanks.
I had a question. Since you save all the data for all the days since 9 months ago, it would be really nice to have a feature to like see how it evolves during the time. I would submit a pair. Maybe, maybe I don't know.
Please do that.
But my question was, did you already look at the data and also already seen like some changes in different runtimes? And can you tell us more about it?
Yeah, definitely. So you're definitely not the first one to ask that, and I definitely need to do some stuff around that. Maybe a small bar graph to show the evolution over time. But yeah, for instance, I gave the example of Node.js 18. When it was released, I'm not sure when, like about 6 months ago, the init duration was higher than Node 12. So not good for Node.js. So AWS did their homework and improved over time the runtime. And now it's beating Node 12. And to be honest, Node 12 is now deprecated, so you cannot use Node 12. But I think it's we can see live. But I think it's better than I don't know. Node 16 is still slightly better than Node 18, but yeah. But yeah, definitely variation over time would be nice to have. Yeah.
Thank you for the presentation. Quick question, I'm curious about Snapstart.
Yeah.
Because you destroy the environment every night.
Yeah.
So you cannot really reuse the snapshot from Snapstart?
That's a good question. I didn't show it, but there is a special case for Snapstart. For every other runtime, I just deploy one function. For Snapstart, I've deployed 10 versions of the exact same code and invoke it, and then take the restore duration. So 10 is not that great amount of Snapstart, but yeah, I could do 1,000. It would have been a bit better, but yeah, 10 is fair, I would say.
Thanks for the talk. I've got one question. It's a very eventful world, and I imagine maybe Amazon could be publishing some kind of event that say, hey, we've updated the runtime. Could you run it again? Then you wouldn't have to run it every day, just when it changes. Yeah,
but this is a good question. But this is maybe true for managed runtime. But let's say for Rust, they do not have support out of the box for Rust, so you need to use. Actually, there is a great library managed by AWS, which is AWS Rust Lambda runtime. And let's say, I don't know, for some reason in a PR they add a sleep 10 milliseconds. I don't know why they would do that, but if they're doing like a code change like that, this would reflect on that. And for managed runtime, such as Node.js 18, they do not explicitly say, hey, we've done some improvement on Node.js 18. It's still the same name, but under the hood, it's not the same code. They release, if you look at the containerized version, you can see that almost every day they publish a new container about Node.js 18, for instance. So I guess they're doing some fine tuning on the runtime. So I would need to run that every day. So yeah. And by doing that, as you can see, it's like fully automated. I'm sure not to miss anything, but yeah, good question.
Okay, thank you very much. It was
cool.
great.
Thank you so much.